Now after that, in coordination chemistry or the complex compound, we take Werner's theory of coordination compound. Werner's theory of coordination compound. Alfred Werner was known as father of coordination compounds. Alfred Werner, father of coordination chemistry. And he gave in the following postulates is that postulates are, first point, every central metal atom possesses two types of valencies, that is primary valency and B is the secondary valency. Second is the primary valency is ionizable, while secondary valency is non-ionizable. Third, primary valency is called as oxidation number, while secondary valency is called as coordination number. Last point, primary valency is satisfied by negative ligands, while secondary valency is satisfied by negative or neutral ligands. For example, if I would like to explain that primary valency is called oxidation number. If I say PTCl4, COCl3, CuSO4 and AgCl related to x minus 4 equal to 0, so x is equal to plus 4, it is the primary valency. X minus 3 equal to 0, x is equal to plus 3. X minus 2 equal to 0, x is equal to plus 2. X minus 1 equal to 0, x is equal to plus 1. Right, so this is what, these are the primary valency. What about the secondary valency? That can be satisfied by the negative, neutral or even cationic ligand. These are the primary valency. So far as the secondary valency is concerned, PtNS3 whole twice Cl2, even I take 2 positive. So 2 plus 2, secondary valency is called as coordination number and your answer is 4. Like this, CrH2O whole 2 Br2. So secondary valency is, what is that, 4. If I take Cl3 6 times water, right? So if they undergo ionization to give 3 moles of this compound in solution, so question may be, what is the secondary valency? The ionizable part must be out. So here you write the chromium H2O whole 6 Cl3 because 3 parts are ionized. So total number of ligands containing coordination number is the secondary valency. So what is the secondary valency? Secondary valency is equal to, what is that, 6. So the way you can have the right answer, the primary valency or secondary valency. But Werner's theory postulates are also suffering from certain drawbacks like this. Drawbacks. Could not explain the magnetic property of the complex. It could not explain the proper geometry of the complex and unable to explain qualitative and quantitative aspect of complex. Keeping these things in mind, now valence bond theory came into existence. Now what is valence bond theory? Important postulates of the VBT that will explain you how to form hybridization. Right. So the next part is the VBT. It is the valence bond theory. So dear students, the first postulates of the valence bond theory is that every central metal atom provides, first point is every central metal atom provides vacant d orbital to take or accommodate lone pair of electrons from, what is that? Ligands. Every central metal atom will provide the vacant d orbital to accommodate lone pair of electrons from the ligands. Ligands are the chemical species capable to donate lone pair of electrons so that central metal atom could accept and coordinate or dative bonds are formed. Right. The second point is, if coordination number is 4, then shape of complex is either tetrahedral with sp3 hybridization or a square planar with dsp2 hybridization. But if coordination number is 6, then shape of complex is octahedral and hybridization may be sp3d2 or d2sp3. There must be some differences between sp3d2 and d2sp3. How do you make the difference? They are entirely different. Yes, important point. Third is, if n-1d orbital is involved, then the shape of complex is, then the shape, don't write the shape, then the complex is inner orbital or low spin. But if nd orbital is involved, then the complex is outer orbital and high spin. Right. The next, second last point is the, see, if two types of the ligands are there, first the strong field and second is the weak field. You have to retain or remember the name of the ligand. If a strong field ligands like cyanide, like carbonyl, ammonia and oxalates are present, then important point, then pairing of electrons takes place in the subcell. But if weak field ligands like fluoride, chloride, bromide, iodide and aqua water are present, then no pairing of electron takes place. And finally, in case of unpaired electrons are present in D subshell, then complex is paramagnetic and colored. If not unpaired, then complex is what? Magnetic, diamagnetic and colorless. After all, VBT also suffering from certain shortcomings. You know what's the shortcomings suffered by the VBT, valence bond theory? See, the first postulate, first drawback of the VBT is that drawbacks. First, unable to explain the quantitative or qualitative approach of complex. Could not make proper difference between a strong and weak field ligands. This is all about the postulates of the VBT. Now see, dear students, solve some question that is from your textbook NCERT. Question is exercise question 9.15. See the exercise and solve the question based on the VBT. What is that question? Just I take 1-2 questions, rest of you will be able to solve. Right, I am very much hopeful that if you carry all these postulates, then you must be able to solve the question. 9.5 question. Explain shape, hybridization, nature of complex magnetic behavior, etc. Question is 1. Question is FeCN6 4 negative. FeCN6 4 negative. Yes, friends. So second question is that FeF6 3 negative, and the third question is COF6 3 negative. Now, first of all, you solve this question. First, write the IPAC nomenclature. Hexa, cyanido, ferrate, second iron. Right. First, to write the IPAC nomenclature, because oxidation state is very important. It will lose the electron like this. Iron, you know atomic number of the iron 26. Make the short configuration by making the use of the inert gas. The best possible configuration 3d6 4s2. Right. But here iron will lose how many electron? These 2. This is the oxidation state. Is very important here. Don't see this charge. No, you take the oxidation number 2 positive. So you write here iron 3d6 4s0 4p0 and 4d0. Because of there is no any problem when you write the vacant orbital. There is possibility to take the help from the vacant d orbital. I know 4s, 4p and 4d. Energy sequence is all right. So what's the wrong with that? If I have put the G 0, 0 and 0, nothing is harm here. So dear student, you write here 36. Thus, and D subcell has how many electrons? D subcell has 5 orbitals. 1, 2, 3, 4 and 5. Apply the Hund's rule of maximum multiplicity you have done in 11th class. So first you write 1, 1, 1, 1 and 1. And then this is the 6. 4s is vacant, 4p is vacant and 4d is vacant. Right. So now this thing here we keep in mind whether this ligand is strong or the weak. Tell me. This is the strong field ligand, because of weak field ligands are fluoride, chloride, fluorido, chlorido, bromido, iodido, aqua. But these are not mentioned here. So always first you look what kind of this ligand. So I have told you cyanide, carbonyl, ammonia and oxalate are a strong field ligand. So pairing of electron takes place in D subcell due to existing of a strong field. There is existence of the strong field ligand. So here you have to mention one line so that examiner will understand and will be very happy to evaluate your answer sheet. What is there now? You have to mention here. It is pertinent to mention due to presence of what kind of ligand? A strong field ligand, that is what it is, the cyanide. So pairing of electron takes place in what subcell? D subcell. So see here, if pairing of electron takes place, then 6 electron is to be paired up. 1, 2, 3, 4, 5 and 6. Then how many d orbitals are there? Here 2. S का 1 चाहिए और P का 3 डब्बा खाली है. इसकी अब जरूरत हमें नहीं है. Therefore, here you take cyanide 1 negative, cyanide 1 negative, cyanide and cyanide. The way you have to write, every cyanide has one lone pair of the electron. So this lone pair you cross it here. 2 electrons are coming. I mean one lone pair from each cyanide. This is the duty. This is the job of the central metal atom to provide vacant d orbital. D has 2, S1 or P3. So tell me, if you have the 6 coordination number, then you require 6 vacant orbital. In case of 6, shape is definitely octahedral and hybridization may be sp3d2 or d2sp3. then in which case it is D2sp3. If it is the strong field ligands are present, then it is the inner orbital complex. It is the low spin complex, right? Therefore, hybridization will be D2sp3, D2s1 or P1, 2 and 3, D2sp3. But if it would have been the weak ligand like chloride, bromide, then definitely I will have to take help from these vacant d orbitals. Then the hybridization will be sp3d2, because these 6 electrons will remain as it is in case of weak ligand. But in case of the strong ligand, pairing of electrons takes place in D subset. It's all right. Therefore, the hybridization will be D2sp3. Then tell me, all electrons are paired up in the D subset. So this is, first of all, what is the shape? Shape is very much clear. It is octahedral. It is diamagnetic or paramagnetic? It is diamagnetic. It is colored or colorless? If anything is diamagnetic, it is colorless. Since D2 orbital is involved, so it is the inner orbital complex, or you can say low spin complex. So all the answers are assembled here in case of that is the D2sp3, octahedral, diamagnetic, as well as colorless, inner orbital complex and the low spin complex. All these criteria is defined by strong field ligand. I hope it is clear to everyone. So last question, I take the case of weak field ligand like fluoride. So just go for, and then next you will have to solve it like this. So here you change this question like, C2O4 whole thrice, right? C2O4 whole thrice, C2O4 whole thrice, and then FeF6, 3 negative. Now take this one. What is the IPAC nomenclature of this compound is? FeF6, 3 negative. FeF6, 3 negative. Hexa fluorido ferrate, third iron. First we again write the same atomic number. Argon 3d6, 4s2, 4p0. It is the ground state configuration. Again 26, how much oxidation state? 3. Take 3 positive. It is the excited state. You can write here, no problem. Ground state as well as excited state. 3d5, 4s0, 4p0 and 4d0. Right. So D subset has 5 orbitals. S is vacant, right? P already 3 orbitals and D already 5 orbitals. So 1, 2, 3, 4 and 5. Then it is a weak field ligand. So if there is a weak field ligand, no pairing of electron takes place. So since fluoride is a weak field ligands, so no pairing takes place. Thus it is all right, leave it. Now sp3, then it is the fluoride. You have to write like this: fluoride, 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 fluoride and fluoride. So here lone pair coming from the fluoride ion act as ligand. Now it is very much clear. This is the answer is sp3d2. More the maximum number of unpaired electrons are present, so it is a strongly paramagnetic. A strongly paramagnetic. If it is paramagnetic, it is colored. The orbital is outer, so it is outer orbital complex, or outer orbital complex is known as high spin complex. So you have assembled all kind of answers. This is all about VBT.